information through emails to different organizations, to different contacts. Our intent for a seminar on Siwalik, I've already shared the extensive program in this connection. Obviously, there is no date for that, but today we are having the first talk regarding Siwalik Stratigraphy. The presenter is going to be Dr. Gary Johnson. The organizer for this, the man motivation for this program actually comes from Professor Bob Reynolds, who had been working as a professor at the Colorado School of Mines. So we're really thankful to Bob for for letting us what has been happening in the past on Siwalik series of Pakistan and bringing all these speakers together. We are really thankful to him. I'm really thankful to Mukhtar Ghani from Geological Survey of Pakistan because he's helping us in web hosting. So I'll now let Bob to introduce Gary and take it onward about this program we are planning.
Okay, thank you very much, Irfan, and thank you all for joining us this morning in Pakistan. And you'll appreciate that it's nighttime here in the United States, where we are, where I am sitting, also in Calgary, where Dr. Irfan is sitting. But we send our greetings to you and a good morning. This is the first of a series of seminars on the Siwaliks. The topics will include stratigraphy, geology, paleontology, structural geology, landscape reconstruction, a variety of uses of different tools for studying the evolution of the landscapes. And so we anticipate that over the next several months, there will be once a week a program, and these topics will range across a broad spectrum. They'll be of interest to a wide community. We're going to have speakers from the United States. We'll have speakers from Europe. We've got American presenters. We've got Pakistani presenters. There'll be a wide variety. Our first speaker is going to be Dr. Gary Johnson, whom I'll introduce in 1 minute. But I want to just let you know that we have Dr. John Barry coming as our second speaker. That'll be next week. The following week, we have Abdul Khayyam. We'll speak about structural geology. And then we have Catherine Badgley. She'll be speaking about paleoenvironments. And then we have Hamad Ghani, and he will be speaking about the salt range. So we have the first 5 speakers lined up. I have another 6 or 8 people who are ready and will be coming. So again, this will be a seminar series, and we'll be constructing it a little bit as we go. But you will be seeing flyers advertising the speakers so that you will know what is coming. Now, it's my great pleasure, of course, to introduce Dr. Gary Johnson, who is a professor in the Earth Sciences Department at Dartmouth College in Hanover, New Hampshire. And Gary was my undergraduate advisor and also my PhD dissertation advisor. And so Gary has introduced me to many different parts of the world, introduced me to the geological riches of northern Pakistan. And it's a really wonderful opportunity for us to have him joining us. For him, it's the middle of the night, and he's been very kind to stay up very late to give us this lecture. And I think that I will turn the floor over to Gary, and I'll just mention again for questions, at the end of Gary's talk, we can have a period of maybe 5 or 10 minutes for questions and answers. And Gary's planning to speak for about 35, 40 minutes, so that there should be ample time for people to ask questions at the end of the program. I'll turn it over to Gary, and we'll start the seminar.
Well, thank you, Bob, and thank you everyone else for showing up tonight and tomorrow morning for me and Louis. I'm going to go to a screen share here in a moment, but I thought I'd start out talking a little bit about how I got involved in this project initially. In the late 60s, I had the opportunity to be working in northern India, actually in the foothills of the Himalayas just north of Chandigarh, on a series of Miocene Siwalik rocks. I guess we would probably call them equivalent to either the Nagli or the Dok Patan formations. But as a result of being there over 2 long field seasons, I think my total time in India at that point was about 14 months. I had the opportunity to wander around Pinjore, which is a Mughal era town just north of Chandigarh on the other side of a thrust-tip anticline, and became aware of the fact that this was a locality for the uppermost Siwalik group. And as a result, I was sort of fascinated with this idea of growing structures and sedimentary response to growing tectonic structures and how they may denude and spread their denuded sediments out onto the Indo-Gangetic Plain and so forth. And it sort of stuck in my mind that this was something I wanted to look at some point in the future. I had the opportunity then in 1971 to arrive at Dartmouth College and began thinking about, how to take this story of structure, sedimentology, response to growing structures in a foreland basin margin. And I thought about extending either towards Nepal or extending towards Pakistan, and finally concluded that Pakistan was the place to go, mainly because most of the outcrops were demonstrating almost 100% exposure. It's certainly more arid in this area of the Punjab and Himachal Pradesh that I was working at in India. So in 1972, let me go here to my share screen. Hold on a second. Does everyone see that?
Not yet.
Not yet.
Let's try that again.
Okay, we see it, Gary. We see full screen.
Hopefully you can all see that now.
Yeah.
Yes.
Yeah.
Beginning in 1972, I began having a discussion with Professor Rashid Tarakili at the University of Peshawar. And at the time, he was just a professor of geology in the geology department there. And he and I decided over the course of perhaps a year's worth of discussion that it was maybe time for me to go over there and for him and myself to wander around at least the northern part of the Punjab and perhaps the Salt Range and a bit of the Trans-Indus ranges. And if time permitted, even work over into Azad Kashmir and perhaps as far east as Sialkot, to assess the potential for a future collaboration between the University of Peshawar and Dartmouth College, mainly in terms of something I would call sedimentary tectonics, taking a look at growth structures that we see in the northern foothills of Pakistan, the sedimentary response that we would see. And at the time, at Dartmouth and in some of the other institutions that we were associated with at Dartmouth, there was the new field of paleomagnetic stratigraphy that was being promoted by primarily Neil Updike at Columbia University, who had been working in that field for about 10 years. And we decided perhaps the way to address these issues of sedimentology and sedimentary response to tectonic growth was to develop a timeline for all of these events. And we could do that, at least in the terrestrial realm, perhaps with paleomagnetic stratigraphy. Up to that point, most of the work in that field had been done on marine sediment, but it was a new field in the late 60s, early 70s, looking at terrestrial sediments, at least long stratigraphic sections of terrestrial sediments. And we felt that the outcrops that we saw in Pakistan were ideal for that purpose. As a result of moving around in that 2 or 3 week period in northern Pakistan, we decided to establish a collaborative effort, which we ended up naming the Dartmouth-Peshawar Project. And over the course of the next several years, we brought in collaboration with Columbia University and primarily Neil Updike, Harvard University and Yale University, primarily David Pilbeam, the University of Arizona, which was represented by Everett Lindsay, who was a vertebrate paleontologist, Geological Survey of Pakistan, and one of our first contacts was Muhammad Ali Mirza, and subsequently Oregon State University, in which Bob Lilly and Bob Yates were several of our collaborators. Now, that occurred not immediately, but it occurred over a course of about 3 years for us to sort of assemble a bunch of collaborative efforts, working more or less independently of each other, but occasionally coming together and working in consort with trying to develop a further understanding of sedimentology associated with the Siwaliks. In the process of doing this, we reached out to several potential support organizations, mainly the U.S. National Science Foundation, the National Geographic Society, and 2 oil companies, Amoco, at least in terms of their Pakistan production and exploration effort, as well as BP, or British Petroleum. Internal funding from Dartmouth College was received as well, and additional funding and assistance from the University of Peshawar. So over the course of perhaps the first 3 or 4 years, this effort became fairly robust in terms of its relative support and the number of people involved. One of the early things that Professor Tyler Kelly and I felt was important was to integrate into this type of research students, university students at all levels, which included those that were working towards their Bachelor of Science degrees, those that were working towards their Master of Science degrees, and of course, PhD students. As it turns out, the Dartmouth project, Dartmouth-Peshawar project, over the course of almost 25 years, saw 52 Dartmouth students spend time in Pakistan, working not only in the Siwaliks, but also up in the Skardu Basin and in portions of the Nanga Parbat and Karakoram region of the northern sector of Pakistan. So it was not only a research project-oriented collaboration, but it was an instructional collaboration in which the prime goal, in many respects, could be considered to be the training of students. And many of those students went on in their own careers, bringing their own students to Pakistan and other places as well, of course. And so it's carried on, I would say, with maybe we're into our 2nd generation. I don't think we're into our 3rd generation of students that maybe put their toes into the water back in the 1970s. Now, when Professor Tyler Kelly and I decided to take a look at the Potwar Plateau, the Salt Range, and maybe some of the Trans-Indus ranges, we started our effort leaving south out of Peshawar, which you can see in the upper left corner, sort of outlined in white, the municipality of Peshawar. We drove down to Kohat, subsequently over to Banu, down through a little town called Pizu, about where that N55 number is, and then subsequently down, made it as far as Tank, after having passed through Bain Pass and then moved over to Dar-Ishmokan before we headed north again towards Mianwali, and subsequently spent time in and around the central Patwar Plateau in regions that I suppose we should say are very important to the lithostratigraphy and perhaps biostratigraphic definition of the Siwaliks, namely the type localities of 4 of the major subgroups of the Siwalik. That includes the Kamlial, the Chinji, the Nagri, and the Dokpatan components of the Siwalik group. And subsequently, we moved our way east towards Jhelum and took a look at some regions in the eastern Patwar, or I guess probably more appropriately, the eastern Salt Range, as well as rocks exposed around New Mirpur City, just south of the dam on the Jhelum. We crossed actually over the Jhelum to the Karyan Hills, or some people call them the Pabi Hills, and then worked our way eventually to Sialkot, having crossed the Chenab as well. So before we headed back, and this was over the course of 2 separate trips, each extending a little more than a week, we saw a tremendous amount of very interesting Siwalik stratigraphy as well as structure associated with that landscape. And that landscape, to me, represented really a dynamic landscape, because we could see actually the response of modern stream systems either cutting through, being basically antecedent through structures that are evolving today. And that's a pretty exciting feature to see, where you are in such a dynamic structural setting that you can see sedimentary response to what's going on with uplift. Now, in that regard, I suppose I would say that you could think of sedimentary response as being proximal, things that are happening right close to that newly evolving structure, and a sedimentary response that might be quite distal. So we'll sort of think about that in a little bit, and I'll show you some examples. But the point is, we saw enough during these trips that obviously collaboration, and a very robust collaboration, was established. And I think one of our members here tonight, Muhammad Javed Khan, was one of the first Peshawar students involved in much of the work that we were doing at that time in the mid 70s, and I'm sorry, in the mid 70s and up into the early 80s. Now, most of you are perhaps familiar with the Siwalik group in general and the terminologies involved. As I mentioned before, the type localities of at least 4 of the major units are right there in the central Patwar: Kamlial, Chinji, Nagri, Dokpatan. And the upper Siwalik subgroup is actually characterized by one location in the eastern part of the Salt Range, as well as a site over near Chandigarh in India. Now, on the left of this diagram, you might see sort of a composite cartoon representing what I will call a typical fluvial cycle. A cycle of sedimentary accumulation associated with processes in a typical loosely meandering or highly meandering stream. We can think about point bars that move in a lateral sense when they grow and leave behind a package of rocks that represents roughly the depth of the stream responsible for that lateral movement. And of course, streams flood and they overflow their banks and they create natural levees, and they actually even top the natural levees. Those materials are comprised of sediments that are deposited sort of in a vertical sense, with slack water or quiet water settling on top of a floodplain and allowing the particulates to settle out. So we can differentiate river-dominated sedimentary systems in two ways, something I'll call lateral accretion, that basically the channel deposits, and vertical accretion, basically the floodplain deposits. So if you look at the composite column on the right-hand side of this diagram, you see in black everything in a very cryptic way I'm expressing as vertical accretion deposits, basically floodplain deposits, and everything that's more or less white are representing sandstones, and primarily the lateral accretion deposits, the channel deposits. Well, what do you notice here? The comleal is consistent with perhaps at least 50–60% dominated by channel systems. The Chinji is sort of parsed by equal partitioning of both floodplain deposits, in other words, vertical accretion deposits in black, and channels. We get up into the Nagri and it kind of goes back again. There's thicker sands and thinner overbank deposits. And we get up into the upper Siwaliks and it's a variable thing, but you can see the dominance again of floodplain deposits. So by definition, some of these formations seem to have characteristic behavior. And the Nagri stands out for many of us as being a sand-dominated interval, and the other two lying above, the Dokpatan and the Chinji, are intervals that seem to have, at least in their typologies, a dominance of potential floodplain deposits and so forth. Those are kind of interesting because, think about it, as we look at some way to look at the preserved record of vegetation or biota of a variety of types, most likely they may be found in rather fine-grained deposits of the floodplain as opposed to the rather coarser deposits of the channels themselves. So by definition, in that regard, the Nagri formation is a little bit less fossiliferous than the Dokpatan or the Chinji. It's a matter of preservation potential. So when we look at those type localities in the central potwar with the Comleal location, Dokpatan location right along the Swan River, Chinji down there to the south, and Seti Nagri, those going back to at least 1910, or possibly a little bit earlier, represent the paleontological definition of the Siwaliks, which unfortunately became the lithologic definition of the Siwaliks. To the eastern salt range, we have the Tatrot beds, named after the village of Tatrot. And if you look down in the lower right-hand corner of the map, you'll see the word Pinjor, but we have to go about 250 kilometers to the east to the vicinity of Chandigarh, India, in the Haryana state, or maybe it's Himachal Pradesh, to find that location as a type locality. Now, what do you see here as a lithostratigrapher or a biostratigrapher? I think you can see locations that are not in context with each other. So even though they may be a type locality, they are not part of one continuous succession in which we can look at time or accumulation over many kilometers in continuous section without a gap. So therein, there is a problem, and it sets itself up perfectly for us to look at some mechanism by which we can affect correlation. Ultimately, that's going to become paleomagnetic stratigraphy. Now, the Eastern Salt Range, this area that I was commenting about, the type locality of the Tatrot Formation, if you look in that reddish splotchy area to the upper right of this map, you see Q US, meaning Quaternary Upper Siwaliks. And I've underlined on this map tatrode. So this is the type locality of tatrode. The unfortunate thing is, if you move south from the village of Tatrode you'll see a little circle with a dot in it and a number 136, which happens to be Edwin Colbert's fossil site 136 in upper middle Siwalik rocks. We cross a kind of a blue line there, and that blue line is actually a disconformity. So here we have, at least in this locality, not a continuous succession, but one in which there is a gap in the record. How long the gap? It may be very short, but it could be. And as we wandered around the Eastern Potwar in particular, Rashid and I noticed that, there's pretty good sections in a lot of places, but there's also a lot of these intra-formational disconformities that are leaving some unknown amount of time not represented. And therein is the problem, I think, fundamentally the problem of much of Siwalik stratigraphy. We just don't know how much is missing when we look at some of the sections that represent allegedly continuous depositional records. Think about it. Each channel system that is establishing itself across a landscape is actually cannibalizing material that was laid down previously as it migrates along back and forth as a meander belt or as a braided stream system. So there's built-in, call them disconformities if you'd like, within most fluvial successions. And the amount of missing time is, for the most part, not determinable. So I put together this little diagram to try to illustrate the points that we think are important when we begin to look at lithostratigraphy and tie to it certain issues that could relate to chronostratigraphy, or the development of a story of time. Perhaps fossil content could help us along that line. Certainly that field of magnetic polarity stratigraphy is something we could make use of, as well as perhaps the occasional volcanic ash layer, if you can find that, and then date some of the cogenetic minerals associated with that. Perhaps, potassium argon on biotite, perhaps fission track on apatites or zircons, or maybe, well, let's just stick with those two right now, and we can look at some other zircon mineralogies that are important, uranium lead dating and so forth. But we can do a lot of things establishing time in stratigraphic successions. And I use this particular diagram for another purpose, just to illustrate that during a magnetic polarity transition, the large circle on the right suggests that, it may take several thousand years before the magnetic character of a rock could change from what we call one polarity to another polarity. We'll be hearing more about magnetic polarity stratigraphy later in the hour, or later in the series of lectures, as well as dating of volcanic ash materials and so forth. But for the time being, just something to think about. A stratigraphic succession contains a lot of information that can provide information about time. And what we need to always think about is, at least for the Siwaliks, something that's only 10 or 20 meters thick is not really going to help you much, because you don't really know how much time could be represented. It's just a little snippet. But the Siwaliks themselves lend themselves to looking at kilometers worth of continuous succession. In the course of our work, which has looked at something pushing 50 stratigraphic sections, Some of those are in excess of 2 kilometers in thickness, continuous deposition. That's what you want, a protracted record of depositional context over time. And of course, the appropriate lithologies in which you can do something with those, or the appropriate fossil content that may also be of use. So time is important. I think all of us as geologists, we may be looking at rocks, we may be looking at fossils, but the important thing that I think most geologists should recognize is that by determining age and duration, you can determine rates of a process. You can determine age and duration and rates of evolutionary processes of organisms. The fundamental takeaway, I think, is all of us that are working in sedimentary successions are very hopeful that we can come up with with enough data that we can talk about the rates of accumulation, rates of denudation, rates of propagation of various facies across a landscape, rates of soil formation on fossil soil formation on landscapes. Rates are what we're after, but we have to get at rates by looking at elements of time that could be preserved in the rock record. Now here's a diagram that Bob Reynolds created a couple of years ago, but it illustrates a couple of points that are very important for us to consider as we look at the southern margin of the Himalayas. And in this case, why don't we just have a very cryptic representation of the frontal foreland fold belt to the right on this block diagram, and somewhere out on the endogangetic plain to the left. But the point is, we have not only rivers cutting through, in other words, antecedent to structure, as they emerge from the frontal regions of those deformed, uplifted rocks, primarily in the form of a braided stream, but ultimately can become downstream a more coherent meandering stream. So source proximal, source distal, and the relationship that has to do with the type of sediment that's being transported and the character of the riverine facies that you're likely to encounter. On top of that is the whole story of subsidence. So I'm not sure if any of you are seeing me while I'm showing this particular PowerPoint, but I want you to think about subsidence and sediment supply. And sediment supply can be from the source, but as we are splaying material out onto our, in this case, the endogangetic plain or somewhere in the floodplain of the Jhelum River, the Chenab River, or the Indus River, that is subsiding. So we are accumulating, we're bringing material in, but we're also taking it out of the record because we're subsiding it. We may be subsiding fast, we may be subsiding slow. That's a tectonic thing that you have to interpret later on based on the data you have. But the point is, at the source area, we're going to have a very unstable system close to the source area. And out here ways, it's going to be very stable. So meandering streams in the extreme downstream direction, in this case, closer to the so-called hinge line of that area of subsidence, are not going to they are not going to leave behind much of a canalized structure. It's going to be relatively complete. Let's look at that area near Sialkot. We crossed the Chenab River, and as you look north toward the Himalayan frontal fold belt, we have the so-called Chenab reentrant, and you can see braided stream deposits emanating from newly evolving thrust tip anticlines or antiforms on the margins of that reentrant. And we have coalescing of those braided streams until we have the principal channel just to the west of Sialkot of the Chenab, still somewhat braided, but becoming progressively more meandering if we were to go farther south. Moreover, let's go over to the Transindus and take the road between Bain Pass and Tank to the south. And we pass a good example of an emerging structure. You actually can notice on the right margin of that anticline almost vertical beds, but there are two streams that are dominant and a couple more that are subordinate that are cutting across that structure. So those streams predated the structure, and it's uplifting and obviously constraining depositional patterns both in the upstream portion before the structure and in the downstream portion before the structure. So these types of things are kind of exciting, I think, when you begin to see the dynamics of this foreland fold belt. And I want you to think about these stream issues that I've mentioned here previously. The lateral accretion deposits are those related to the channel sands that are, for the most part, created by the lateral movement of the stream, be it braided or, in this case, nicely meandering. But as that stream may flood and top its natural levees, it can have splay deposits. It can have slack water deposits in the form of small ponds or maybe larger bodies of water. But at any rate, surfaces that are somewhat stable, floodplains in general, that can then develop fossil soils and preserve some record of ancient environments. The terrestrial environment, the riverine fringe environment associated with all sorts of vegetation and so forth that may be preserved in the rock record. A sketch that I thought about, maybe I shouldn't have put this in, but here's our Chenab River. If you think about it, on the right is our source up in the evolving foreland thrust belt. Highly braided streams coalescing as they emerge from the thrust fronts and these small aniforms that are developing. Eventually going into a system that's more structurally meandering. And just like that emerging anticline that we had over there by Bain Pass or Tank, we have structures that can constrain, at least in the upstream region, slack water development of that river system, cutting through and then ultimately kind of repeating itself with a series of braided stream components going on to meandering stream and so forth in the downstream section. So we can see all of this type of sedimentary response in today's world, but guess what? We see that sedimentary response preserved in the rock record because each of these structures, these little anticlines that are emerging today on the margins, are exposing rocks that were laid down just like the modern ones are, but millions of years earlier. And so the Siwalik formations, Chinji, Nagri, Kamlial, Dokpatan, Tatra, maybe even Pinjor, preserve for us fluvial systems that are responding to exactly the same kind of issues that are characteristic of the foreland margin today. I would make a couple cartoons here, and I could imagine the column on the left is one that represents a pretty good example of what you might see preserved in a river system in which braided streams are dominant. Coupled with basin subsidence means that about all you preserve is a whole series of sandstones. But each of those sands, if you look closely, you can see cut surfaces and essentially what you might want to call little minor disconformities within the section. But for the most part, creating for you a very composite record of proximal deposition in which sands dominate. The middle section is kind of a hybrid with composite sand bodies, but of course occasional overbank preservation as well. And the column on the right represents a better example of a river system in which it's dominated by simple meander belt fluvial deposition, fossil soils, conkers, which are nice calcium carbonate concretions that you find in the B horizon position of fossil soils, splay sands, overbank muds, maybe even preserved deltas, levees associated with that proximal river system. So, you can look at this kind of variation, and there's infinite variability between these. But on the one hand, you could say, on the left, this is sort of Nagri-ish like in the type localities, and where many people have seen these multi-faceted Miocene sand-dominated fluvial cycles. It's sort of the Nagri formation. Well, maybe yes, maybe no, depending upon the time. Dokpatan is very typical of what you see in the middle column, and the Chinji is very similar to what you see on the right-hand column. So if we look at the Chinji formation and its type locality, what do you see? You see some wonderful examples, at least in this middle view, a nice sand body that's about 2 meters thick, and it has slightly inclined stratification that goes from right to left. This is a good example of a point bar caught in cross-section. And we see paleosols beneath. We see paleosols above in the red beds. We actually see a few splay deposits. So this is a good example of what we just saw on the right-hand column right here. Single-storied facies, in the sense that the single story means the lateral accretion rocks overlain by vertical accretion rocks. That's part of a package. So when you look at this particular column on the right hand, starting at the base, we have cycle A, B, C, D, E, up to G. Cycle B is a good example, starting out with a channel and then its associated overbank deposits. So this is what we mean when we see these kinds of composite single-storied facies. Maybe a cartoon that's not worth spending too much time thinking about, but when you start looking at this complex of multiple channels, lateral motion, lateral accretion, and vertical accretion, this is kind of a landscape issue that is, in some respects, reasonably stable. It's not a good example of a braided stream system. It's more appropriate for either Dokpatan or some of the Chinji formation. But nevertheless, if you look down at the column A down below, it's basically our lateral accretion and overbank deposits associated with it that can get fossil soils associated with them. As we look at some of these areas, and this in the northern part of the Sugar Range, we have, and in fact, you can see the partings in here. This cliff face is about, I would say, 25 meters high. And you can see overbank deposits towards the top, but large sand bodies as well. This is composite and somewhat braided in its character, with a few fossil soils preserved as well. Another example, which gets us closer to sort of source areas, is this, and this is also in the Transcendus, but shows massive sands as well as massive gravels that are interpreted as braided stream deposits being quite proximal to their sources. And if you look at some of the gravel bodies themselves, the clasts are actually recycled Siwalik rocks, in addition to other things. And finally, and this one is about 30 meters high, excuse me, from the stream bed at the bottom to the top, and it's massive conglomerates. So, or what we might call mixed gravels and so forth, with a few sand facies. So, all in all, we can look at much of the Siwalik record as one of source proximal to source distal, stream proximal to stream distal. When we say stream distal, we mean well out on the floodplain away from a channel, so we have a chance to have very good fossil soils developed. Excuse me, I have to cough. Now, one of the things that we happen to discover, and it's very random and very rare, but they're there, is some volcanic ashes. This was complete serendipity, as they say. The literature for the Siwaliks does not, and I should say, I should repeat that. Up until the discovery of these volcanic ashes in the 1970s, the literature historic, going back to Sergeant Cautley in 1854, when he found the first fossils in the Siwalik hills of somewhere near Dehradun, India. There has never been a mention of volcanic ash beds or tuffs in the Siwalik sequence. We have now found at least 18 in the interval between about 3.3 million and 1.6 million. Plus, we've found two more, one at about 9 and one at about 13 or 14. Exceedingly rare. Where they're from, we think from a volcanic center in central Afghanistan, just west of Ghazni, the so-called Dashni Noir. But it allows us to provide a timeline for our depositional systems. And we can also provide correlation from one outcrop to the next. When you think about it, the opportunity to follow a sandstone body across the landscape, particularly a sandstone body that is not a beach deposit related to very simple timeline associated with the shoreline position of some ocean basin, we're looking at sandstone bodies that are river systems. Those are not continuous. And so laterally, they are discontinuous. In the Attic Basin, just south of, southeast of Hazek, I guess it used to be called Kambulpur, we've been able to find quite a few of these bentonites, volcanic ashes that have been altered a little bit, with most of the glass that would have been part of the original depositional system having been converted to an expandable layer clay. And towards the base of those sands, or sandy units, we were able to sample and find detrital zircons and cogenetic zircons from primary airfall, as well as biotites and so forth, and made use of that material to affect dating. That dating allowed us to then subsequently calibrate many of the efforts that we did independently to establish paleomagnetic stratigraphies. It also allowed us to affect correlation between outcrops when we were just looking at field relationships. So they're very useful timelines. Sort of in a summary of what the whole story of the Siwalik depositional record is we can think about back at sort of the base of the Kamlials or the Murray formations beginning around 20 or so million years ago. The first record of, at least in this part of Pakistan, the depositional remnants of previously eroded landscapes that are accumulating in the Foreland Basin. And over the course of this 20 million year interval, we accumulate something on the order of 6 to 8 kilometers worth of section. In a few cases, we've got this interbedded series of tuffs or volcanic ashes. And then, of course, we have the opportunity to provide some sort of dating as well. First cycle zircons really refers to the fact that those zircon crystals, zirconium silicates, are derived from a volcanic process. That's the first time they've been introduced to the rock record and are not recycled from something else. So, after having made a fairly concerted effort over the course of the first several years with this Dartmouth-Peshawar project, we decided that our goals, although initially sedimentary tectonics, sort of number 4 in that list, were also useful for helping out establishing biochronologies or assisting in the paleontology efforts that in this case were conducted primarily by folks from Yale, Harvard, the University of Arizona. We could do fission trap dating, and we were able to do essentially magnetic polarity stratigraphy dating. And we spent most of our time thinking about those rocks flanking the Himalayan Foreland Basin, basically in the form of the foothill belt, the Salt Range, the Pawar Plateau, the Peshawar Basin, ultimately going into the Kashmir Basin in India a few years later, and even going up and taking a look at the Buntong sequence just north of the town of Skardu in a broad reach of the Shyok Indus River landscape that we have up in the Skardu region. So we branched out, and at least in terms of the sedimentary efforts, and of course, as I said early on in the talk, we were significantly involved later on with work around Nanga Parbat and up in the Karakorums as well by other faculty members at Dartmouth and their students. Now, recently, Bob Reynolds has been putting together sort of a synopsis of work that has been done over the course of 25 years or so in regards to the Siwaliks in terms of both mapping and developing chronostratigraphies and maybe some assistance in biostratigraphies. And I want to just take a brief moment to show you an example of what we're able to do with the data we have. And Bob's effort has done a superb job in demonstrating how effective a technique can be to establish timelines in a structure. Now let's take a look at the Eastern Salt Range. This little box here in the lower left center, the bigger red box, is essentially that area that showed Tetrot and the map that Ed Colbert had done in the region of Tetrot back in the mid-1930s. Well, what I'd like to do is illustrate what basically one of our first major contributions to the structure and depositional record and chronostratigraphy of the Siwaliks was back in one of our earliest papers in, I suppose, 1977 and 78. First one that came out as a result of all of this work. And it's going to be based on something that H. Michael Keller did for a thesis research project on the Bobby Hills. Now, that was published in the Earth and Planetary Science Letters in 1977, and it was sort of a test case for how we could look at emerging structures, magnetic polarity stratigraphy, a bit of lithostratigraphy, and make essentially a good interpretation of what a landscape element can provide for us in terms of structural dynamics and everything associated with that. Mike Keller, Rashid Tariq Kelly, Muhammad Ali Mirza, and myself, Noy Johnson, who was also at Dartmouth, and Neil Updike from Columbia, we put this together, but based mainly on Mike's work. And if you notice the map at the bottom, all the little black dots and the white dots, we're actually tracking outcrops along the railroad system between Lahore and Rawalpindi. And it cuts through the Karyan Hills or the Poppy Hills very effectively, giving us 100% exposure in a very interesting and easy way to sample. You're right along the railroad cuts. But nevertheless, the lithostratigraphy is illustrated at the top, and the structural form is illustrated sort of in this cross-sectional thing that you see with kind of a hump in the middle, and then it's dipping at 20-some degrees to the northwest or southeast. Now, next slide. Same map, but I've included at the very top of the diagram our interpretation of time based on the character of the magnetic signature. What's important there is that it shows that in the youngest mode, off to the left, we have inclined strata that are probably about 600,000 years old. So that's to say that this structure began growing at about that time, or maybe a little bit more recently than that. But at least as far as we could go until we ran out of outcrop on the flanks of the Jhelum River, we could get down to about 600,000 years ago on the extreme left of that diagram. So this tells us something about timing. You know, these structures are really young features on the landscape, and they are continuing to grow and will continue to grow in the future. You can see the GT road from Karyan to Jhelum, and the line of traverse was just parallel to that along the railroad. The magnetic polarity stratigraphy that I just showed previously is in a little diagram to the right in white. But the ability to turn that temporal statement into a map component in which we can literally take that entire Poppy Hill structure and illustrate time associated with it. The Jaramillo, the Bruns, the Olduvai, the Gauss, these represent time intervals going back to about 3.8 million years. Maybe a simpler way to look at it is the timeline. A 3 million year timeline, a 2 million year timeline, a 1 million year timeline. Now, what does this mean? And I think Bob has very elegantly put this together. You can walk out to this structure right now, and you can get in yourself the first set of outcrops. And if you happen to be in the middle of that pink area, you know that your rocks are less than 1 million years old. And if you're in the yellow area, you know you're in a sequence of rocks that are between 1 and 2 million years old. And in fact, that entire traverse in the central part of the Poppy is a fairly young system. And if we work down towards the southern southwestern flank, you can get rocks that are older than 3 million. But you know, the point is, we have timelines that can be established now. This goes back to the premise that we had decades before. These maps, by the way, were just made this last year. Decades before, in which time is important. Time allows us to establish rates of deposition. It allows us to determine rates of deformation. And in this case, time allows us to do a predictor of the age of rocks you have. If you're out looking for fossils, you kind of know where you might be. So up to this point, we've saturated much of the Potwar Plateau, the Eastern Salt Range, and the area of Azad Kashmir, and quite a bit of the Trans-Indus with some of our stratigraphic efforts. I think if you count the dots, you're pushing about 50 of them here. And some of them are obviously composite dots. There's a whole area in the Western Potwar that still remains to be looked at, and that is prime territory for someone else to jump in here and take a look at this rock. So in summary, it's been a number of years that we've spent time. Over 50 Dartmouth students were trained and had the opportunity to do real science, and many of those were able to publish their work. I'd say more than half came through with very good publications as a result of their work. The collaboration with University of Peshawar and the GSP was superb. And I think, it points out that, interdisciplinary, interinstitutional collaborations can be very successful, and they can last a long time. One of the primary goals of this project was for us to not only study those rocks, sample the rocks, make the interpretation, collect the data, but what was paramount in our initial discussions with Professor Tara Kelly was that any work that has to be done should be documented. We should be able to make use of aerial photos and topographic maps and show exactly where our sample traverses were conducted. And this should be recorded not only just in the private field notes, but also in publicly accessible documents. And you ask the question, well, why? Okay, here we are in 2021. Some of these sites were looked at in 1980 or 1990, or maybe even earlier. If they're well documented, you can go back and fill in the blanks. You can continue the process. You can continue to expand the data set by knowing where things were. Of course, it makes it easier now because we have GPS, and you just bring your cell phone along and you can figure out where you are. And every sample that's ever taken now in the future will have a latitude and longitude line associated with it in your field book. Well, thank you for staying with me. And again, the Siwaliks are an exciting sequence of rocks. They're complicated. It takes a while to wander around and try to figure out what you're seeing, but it can be done. And it's probably the best place in the world to look at long stratigraphic sections that provide a window to the past, both paleontologically, paleoclimately, and tectonically. So with that, I'll turn it back over to Irfan or Mukhtiar or Bob. And
thank you, Gary, for giving us this broad and wonderful introductory lecture. I think you've set the stage for a variety of lectures that are going to be coming up over the next several weeks and months. And I think that the stratigraphic record that you've introduced here really is the template upon which a lot of the additional studies are being done and will be done in the future. It's late, I know, Gary, where you are back in New Hampshire, but maybe we have time for one or two questions. If there's somebody who has a question, perhaps Irfan, we can listen for one or two questions.
Yes.
Sure, yeah.
So I'm not hearing a question right now, Gary. I might ask you. You've you've shown us a lot of the different stratigraphic studies that were done. One of the things that I found most interesting about this whole project was your personal collaboration with Dr. Tarhelli, and you might maybe tell us a story or two about Dr. Tarhelli. I know he came to visit the United States many times, and perhaps you could give us a little bit of a feeling about what he was like as a collaborator, just some personal anecdote, perhaps.
Oh, we all have personal anecdotes. Yeah. Both of us came at this, of course, not knowing each other, although we had communicated by mail for probably a good 3 or 4 month period before we finally met. But immediately there was a synergy, I think, that worked very well, even though here we were, 2 different cultures, 2 different ages. He was 14 years older than I. No, that's not right. He was about 10 years older than I. And we both had a fundamental understanding that, there's something special about northern Pakistan that tells us about geodynamics and the response of sediments to that geodynamic structure to the north, basically the Himalayas, the collisional zone between the Indian subcontinent and Asia. And Peshawar was perfectly suited for all of us to use as a base. And I think, his history of working in the Karakorums over the years sort of proved that out as well. But, anecdotally, I think his introduction to I just can't replicate that. I'll never forget, we were in Jhelum, staying at a little hotel. I think it may have been Zelof's, but it might have been another one. There was a lot of noise in the streets one night, and we went out, and it was a food festival. And strung along the streets were all sorts of food vendors, dominated by fishmongers, as we call them, selling grilled fish freshly caught from the Jhelum. And I looked at some of these fish and I realized, this is a catfish or this is a carp. And Rashid was really interested in carps. And if any of you have tried to eat a carp, you realize it's mostly bone and a little bit of flesh. And I picked my way through this carp, the one I had, and I had a hard time because it was so bony. He took big bites of that thing and chewed it down and swallowed it all. I mean, maybe this is a cultural thing, I'm not sure. But I had to kid him for years about his ability to handle these spears and down his gullet. Any of you that have had bony carp, you know what they're all about. And he didn't even blink eating this stuff. I must say it was really good, but I had to be very careful because I just couldn't handle it. So
well,
there's so many
had wonderful times. We had wonderful times with Rashid, and I remember he introduced us to chapli kebabs at Charsada, and there's a long list of joys of doing fieldwork in the Peshawar Basin. But listen, Gary, it's getting late, and we're invading your evening. So if you maybe have one, I don't know, Gary, I'll give you the last chance to say something, and then we're going to have to draw to a close. Well, thanks. And, whether I deserve being the first one off the block, I'm not sure, but there's another story to be told next week about Yale and Harvard University and the collaboration with the Geological Survey of Pakistan. So as you begin to weave together the stories of all of these international groups that worked with either Peshawar University or the GSP, the 70s and the 80s and the 90s were a very robust period, and a lot of interaction with
many European universities, North American universities, and these two institutions, GSP and Peshawar, have left a lot of us with really good feelings. I've said this to many people because I spent so much time over there, 3 months every year for 20 years maybe, that it was truly a second home for me, and I still feel that way. So, I think, Bob, you having lived there with Mary for a year and then having many visits, you probably feel the same way. But I think a lot of us sort of feel the same way, that it was just a very hospitable experience. I was looking for it the other day. There's a wonderful comment by a British geologist that spent time in the Poppy Hills in the 1990s, talking about his feelings. And he said the most enjoyable time that he had as a professional geologist was the time he spent working in the Poppy, in which he was collaborating with the GSP. And he felt that just learning how to collaborate in a completely different culture was something that is hard to replicate. And I think most of us that are being introduced to this topic over the next several weeks can probably say the same thing, that all of our field experiences were something we will never forget, and are truly thankful that we were able to do it.
Good. Well, thank you, Gary. And I'd like to underline your points there, and just in our final comment here, just make the point that this seminar series does reflect what you're describing, and we're going to be hearing from a wide variety of workers in different disciplines, and the links between the geological community across the world are strong, and relationships that were established many years ago in Pakistan and working in the Himalayas are still alive today. And you're going to be hearing, as you join these seminars, from a broad range of workers, and you'll hear a common theme of continued interest in understanding the geology and the evolution of the Himalayas and the Himalayan foothills. So I think with that, I'm going to thank everybody for your participation this evening, and I will invite you to join us 1 week from tonight, and we'll hear from Dr. John Barry, who's with Harvard University. So thank you all very much.
We'll introduce as well. Thank you very much.
Yeah.
Thank you. Thank you.
Thank you.
Sure.
Thank you all, and Hoda Hafiz and Pir Malenge.
Yes, inshallah.
Thank you very much.
Thank you, John. Thank you so much.
Okay.